Hello Math 7 students, this is Open Up Resources Unit 3 Lesson 9, Applying Area of Circles. To get started we have this quick pull warm-up. The diameter of a circle is 12. Using that, what is the area? Be careful on this one, make sure you understand what information is given to you and what information I'm asking you to find. Pause the recording and make sure you get this answered. In this example, I give you the diameter. The diameter is 12, but remember that whenever we've talked about area, we talked about area is the radius, which is squared, and then multiplied by pi. And so since I'm not giving you the diameter, since I'm giving you the diameter and not the radius, we need to use that in order to find the radius. And I remember that in order to find a radius, I just take that diameter and divide it by 2, and that will give me the radius. So again, the diameter divided by 2 is the radius. Now I know what the radius is. So I square that radius, multiply it by pi. A precise answer would include pi, so 6 squared is 36, and 36 multiplied by pi. I had just one student enter that into their calculator. The rest of you guys actually did the 36 times pi in your calculator, and I got some sort of approximation. 113.097 is accurate to 3 decimal places. Some students rounded a little bit earlier. Rounding to the nearest tenth has kind of been our practice, and that would be 113.1 if I'm rounding to the nearest tenth. Things to take into consideration: I didn't give you the units, so this would just be 12 units. What would the units be when I find the area? Have a quick discussion with your groups. So do I just keep it as units? What do I do, Davin? Exactly, it's no longer units. Whenever it's area, it's square units, so units squared is appropriate. On each one of these, don't just stop at units. It needs to be units squared. Now let's move on to the lesson. Unit 3, Lesson 9, Applying Area of Circles. This problem starts off by giving us an approximation of the area of this field. Have you guys ever seen that, especially if you've been in a plane? Have you seen those circular areas? Why do they have them circular areas? Why not just keep it a square of crops? Any ideas, Joshua? Exactly. Exactly. So this is like the pivot point. Each one of these is a big giant wheel that holds this big long arm of sprinklers. And the way that it moves is those wheels spin in a circle, and so this is just the area that it covers. It's a pretty efficient way of making sure that all of your crops get watered, but that's why they don't plant any of the crops here in the corners, because they will never get that water. So yes, that's exactly why, and you can see that this arm right here that does all the watering, as Joshua pointed out, that is our radius. So it gives us an approximate area, and it says, what is the field's area to the nearest square meter? Assume that the side lengths are exactly 800 meters. So this is 800 meters, this is 800 meters. Interesting. Based on that, what information is it actually giving us? If the side is 800 meters, what is that measurement called, Cambria? Say that again, I'm sorry. Yeah, it's giving us the diameter. So if I'm looking for the radius, or excuse me, if I'm looking for the area, just like on our warm-up, that means we need to take that information of the diameter that it's giving us, find the radius so that we can then answer the question. As you do this, I want you to understand, in this class, I have focused on always using pi, the calculator's version of pi. In almost all of our problems it says, use your calculator's version of pi. But not everybody has pi programmed into their calculator if they're not using a very fancy one, so what if we just use 3.14 because that's what we have memorized? What are we going to find? So I want you to do that now. Calculate using just 3.14. Who, without cheating, who knows a couple more digits of pi? Okay, Alexis, tell me a couple more. 3.14159. Okay, so there are some other approximations. We can use the calculator's version of pi. We can use 3.14. We can use the approximation 3.14159. Give that a try. Find the area using different versions of pi and see what you end up with. I'm going to pause the recording as students work on this. Ready, set, go. All right, as we've already established, the diameter is 800 meters. What does that make the radius? Again, we take that diameter, divide it by 2, and we get, Carter? 400 is our radius. So I'm going to take that radius and I'm going to square it. 400 squared, and then we're going to multiply by different versions of pi. What if I start with just 3.14? What is 400 squared times the approximation 3.14? I'm going to type this one into my calculators and I'll call on you guys. So 400 squared times just the approximation 3.14, we end up with 502,400. So 502,400 meters squared. So that would be A, right? Because A is only using 3.14. So we're like, great, we found an answer. A is accurate. But what if we use something that's a little bit more precise, like 3.14159? What do we get when we make it a little bit more precise? 3.14159. Do we get A again? What do we get? Who has actually done that calculation? Okay, great. Let's go, Gideon. Yes. Great. So, what we're seeing, because it does say, I do believe that we are rounding to the nearest whole meter, right? Yeah, to the nearest square meter. So, when you gave your answer, you said we get this. 502,654.4 rounded to the nearest whole would be, well, it's actually rounding up to 55, right? But this would be using the approximation 3.14159. Isn't that interesting? Compare these answers. A, where we just use 3.14, and C, where we use 3.14159. Is that a big difference between those? Yeah, that's a really big difference. 400 meters, 655 meters, that is a difference of 255 meters, right? 255 square meters. Is that a big difference? Yeah, just adding a few extra decimal places of accuracy does have a big impact. Repeat this process one more time using the precise pi. If I use my calculator's version of pi instead, again, that's 400 squared multiplied by pi. Even more decimals of accuracy here. 502, oh, hold on, Gideon. I think they didn't have a 3.14159, did they? Now that I'm actually looking at this. 5.4 would have rounded to 5.4, and that wasn't an option. But this one does round up to that 5.5. Okay, so let's change that one. We're just going to call this one the pi. Here's what I did really quickly for anybody who is not following quite as easily. What I'm saying is when I multiply the 400 squared by pi, the calculator's version of pi, it gives us enough decimal places that our tenths place is going to cause the ones place to round up to a 5.5, which is what we saw here for part C. We assumed that this answer was closest to C, even though technically it did not round to 502,655. This one would have rounded to 654. Key thing is math practice 6. Does using the precise version of pi, does that really make a difference? Is there a difference between A and C? Yeah, a huge, huge difference. And so that's one of our big takeaways today is I prefer us to use pi. It maybe doesn't make a big, huge difference if the numbers are really small, but when the number is very large, like 800 divided by 2, so 400 squared, that is a big number, and that is going to be a big difference in the end of the problem. So again, make sure that you are being precise and using the calculator's version of pi, which we always have, so that's nothing new. I want to move on to this next problem. Comparing areas made of circles. Each square has a side length of 12 units. So let's think about what that means. Each one of these has a side length of 12 units. So I want you to compare the areas of the shaded regions of each of these three figures. Let's do the first one together. If this side length is 12, what does that really mean? Look at when I move that side length up into the middle of the circle. What measurement am I giving you? Liv. The diameter. Hey, that looks really familiar, doesn't it? A diameter of a circle is 12. Here we have a diameter of a circle is 12 units. Now, we know, based on our other problems, that we're probably going to need to turn that into a radius and find the area. But how am I going to find the area of just the shaded region? I don't want this unshaded circle. I want to know the shaded region. So form a plan with your groups really quick. We're going to pause the students' chat and form a plan with their groups, and then we'll go over it. Okay, tell me your plan, Davin. Great. So if we find the area of the square, that's going to be this whole entire thing, right? But we don't want that circle that's white because it's not shaded. So then we're also going to find the area of the circle so that we can subtract them, leaving us just that shaded area. So we're going to subtract, leaving us just the shaded area. Fantastic. So again, I'll find the area of the whole entire thing, subtract the circle that is unshaded, and it will leave me just these shaded edges on the outside. Okay, well, I better not undo it that way. Great strategy. I'm going to pause recording one more time as you give yourself a chance to work on that. Ready, set, go. Okay, what's the area of the square? Even if you're not all the way done with this problem, help me out. What's the area of the square? How do I find the area of the square? Grant. Yeah, length times width. Well, what's the length? And what's the width? So 12 times 12, or in other words, 12 squared. Good. So 12 times 12. And 12 times 12 is equal to 144. The area of the circle. How do I do that? Area of the circle. Liv. Great. Okay, so 12 divided by 2 gives us the radius, so that's why I'm using 6. 6 is squared and multiplied by pi. How many decimals of accuracy did you give me, Liv? Let's go, just for funsies, let's go a few more. So let's go 113.097, just like we had on our warm-up. Okay, area of the circle is 113.097. So what is that shaded area? You told me before that we're just going to subtract that, right? So when I do this subtraction, 144 minus 113.097 is equal to, Cambria? Say that one more time, 30. Did I write that down correctly? 30.903 is going to be just this shaded region. Okay, great job, great strategy. Now here is my question to you. Let's make some predictions. B and C. Do you think that they have more shaded area than A or less shaded area than A? Have a conversation with your tables. What do you think? More or less? Okay, and now come back to me. What are your thoughts? The same, less, more, Oren? Why do you think it's the same? Uh-huh. Okay. Okay, so you're saying since it's the same square, the square isn't really changing, only the circles are changing, but you're just saying, well, there's a lot of shaded space here in the corner, not as much here, but we've got some shaded space here, 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 and here that we didn't have before. So it's probably that little bit that I'm missing from here is probably made up for in some of those extra areas. Okay, let's put our prediction. Is there anyone else who has a different prediction? Okay, let's put it to practice. The area of the square, is it changing? No, it still is going to be that 12 times 12, which is equal to 144. Now, it said before we were going to find the area of the circle and subtract it. What am I going to do now? What am I going to do for this now? I don't have just one circle, so what am I going to do, Luke? Mm-hmm. Okay. Good. Right. So here is this diameter, which is 6, and this diameter, which is 6. So when I divide it by 2 and I get 6, I'm not finding the radius, right? I'm finding the diameter of a smaller circle. Okay, there's the diameter of a smaller circle. How do I use that to find the radius? As Luke said, we divide it by 2 again. So there is a radius of 3 and a radius of 3. So we're still going to follow that process. We might need to do some extra calculations, but we're still going to find the area of the square. We're still going to find the area of the circles and subtract it. We just have more circles that we need to find the area of. Once I find the area of one circle, though, what do you know? They're all the same, right? This circle is the same as this one and this one and this one. So once I find the area of one circle, I can multiply it by 4 and find the areas of all the others. We're going to pause the recording as students work on this problem. Ready, set, go. Okay, let's go over this together. Luke helped us find the radius. When I know that the radius is 3, that means I can find the area. The area is going to be 3 squared times pi. But how many of those circles do I have? 4 of them. So I'm going to take that and I'm going to multiply by 4. Interesting. What's 6 squared? Use your heads. You don't need your calculators. What's 6 squared? Come back here to this problem. Davin. 36. Okay, now this problem. What's 3 squared? Gideon. 9. And will you multiply 9 by 4? What do you get? Huh. That is interesting, isn't it? This ends up being 36 pi with the approximation 113.097. This ends up being 36 pi, which is going to be the approximation of 113.097. And what happens when I do that subtraction? I'm going to get the same thing as I did before, right? 144 minus 113.097 is equal to 30.903. Just as, who made that prediction? Luke. Who made the prediction? I can't remember now who made the prediction. Oren. Oren made the prediction. Okay, C. Is it going to be the same? It's even more circles now, so is it going to be the same? Okay. Let's test it out and give it a try. Same strategy as before. Let's find the area of the square. Subtract the area of the circles. We have more circles this time, so what are we going to do? Again, here's that area of the square, or the side length of the square is 12. What does that mean for our diameters? What does that mean for our radii? Some of you guys have already worked ahead, so we're going to answer those questions now. Joshua. Good. Great. So 12 divided by 3, because there's 3 circles, means each one of these circles has a diameter of 4. 12 divided by 3 is 4. But I don't want the diameters. I want the radius. So 4 divided by 2 to give me the radius is going to be a radius of 2. Continue on with that. I'm going to remember that our process, our strategy is this area of the square, which is still 12 times 12, which is still 144. Joshua, do you want to finish this up? Okay, I'm going to pause there for just a second, though. When we find the area of one circle, instead of calculating that out with pi, tell me this. How many circles are there, Joshua? 9. So I'm going to take that one area and multiply it by 9, because we have 9 of them. Now let's break this up again. What's 2 squared? 4. What's 4 times 9? 36. Same as we got here with our 6 squared, same as we got here with our 4 times 3 squared. So this is still going to end up simplifying to 36 pi, right? 36 pi, I already know that based on all of these other ones. That is going to be 113.097. 0.097. Let's do that subtraction. When I do that subtraction, I'm not going to waste my time typing into the calculator because it's the exact same things we got before. That is 30.903 units squared. Unfortunately, that is all that we have time for here today. So we are going to end this recording. The homework I am assigning students, the online viewers, can also start looking at 2 has these 2 really interesting figures. I want you to see if you can figure out how you can find the area of each of these figures. You can see, if you look carefully, that they're composed of some very similar figures. I want you to see if you can figure out what the area is. Here's the one piece of information that it gives us, a side length of 1 unit. So this square has a side length of 1 unit. That's this piece right here is 1. Since it's a square, this piece right here is 1. So with that in mind, see if you can find the area of each one of these figures. That's it for today. Thanks for watching, and we will see you next time.